Hey, good morning, everyone. Just do a quick video and audio check real quick. If you can hear me and see me, give me a thumbs up in the chat box. All right, very good. We'll see. We'll let a few more people get in. Just make sure. Give a couple minutes for some people to get in here, and then we'll get going. Make sure you have 7.1 notes out. And today we start trigonometry. All right, good morning, guys. Let's go ahead and get going with lesson 7.1 notes trigonometry. This is somewhat of a large size packet. A really good introduction for us to trigonometry. So if you got this packet out and you are here and you're ready to go, give me a thumbs up and we'll get going. All right, good Maddie, good Odette. I mean, not Odette, Bernice, good Kelsey, good Christina. Okay, so let's first start with what is trigonometry. So what in the world is this trigonometry? Yeah, a little bit of change of scenery here. So the question is, what is trigonometry? And really, sorry. Every time Abby talks or sends something in the chat box, I start getting sick. No offense. But trigonometry, the meaning of trigonometry is actually found in the word. The word trigonometry is literally identifies what it really is. So, what is try right here? What does try mean? Okay. Someone type in the chat box. What does try mean? Very good, Lucy. 3. Okay. Try simply means 3. How about gone? What does gone mean in math? G-O-N. What does gone mean? Anybody know what gone means? Like polygon? Okay, not bad. Gon just simply means shapes, or excuse me, not shapes. I read that off loosely. It simply means angles. Yeah, Maddie, you might have been taught early on that polygon many sides, right? But gon really just simply means angle. So polygon, it actually has many. It does have many sides, but it has many angles. But trigonometry, 3 angles. Okay, and then what does ometry? What does ometry mean? And ometry is just another one of those words. You know, we have the in. You know, ology. We have ography. We have ometry. Again, we could have a bunch of different words there, and we obviously know geometry. And what's kind of cool is here is that we could put geology, geography, geometry. We could put G in front of all of that. So the question is, what is ometry? Yeah, very good, Maddie. Measurement. And if you think about an optometry, what does opto mean? Opto simply means the eye, right? So this is the eye or vision, right? So an odometrist measures your vision. Okay? So trigonometry is literally what it is saying in the word itself defines what it is. It measures 3 angles, okay? So 3 angles, we know something with 3 angles is going to be called a triangle. So trigonometry, its basis and its core stems from triangles, all right? And specifically what we will touch base on are right triangle triangles, which have a 90-degree angle in the triangle, all right? So trigonometry, very simple, just 3 angles of measurement, all right? And we're going to, that's our goal, is to kind of deal within trigonometry. And trigonometry really has to do with finding side lengths and angles. Okay? So trigonometry, 3-angle measurement, it has to deal with finding side lengths and angles, and I'll say of right triangles. Now, I don't know how much you all went into trigonometry. I think you all touched on it a little bit in geometry when it had to deal with, and obviously geometry is the measurement of shapes, like many different shapes. But trigonometry focuses specifically on triangles. I think you all did a little bit, but I'm not 100% sure. Can someone confirm? You all have heard of sine, cosine, and tangent, correct? You may not remember how to do it, and if not, that's fine. It's been a long time since you've taken geometry, so. But you all have heard of sine, cosine, and tangent, correct? Okay, cool, Maddie. Do you remember anything about it, Maddie? Just asking, just trying to see. Yeah, we're not trying to cast shade, Abby. All right, cool. So, here is our thing, guys. When we are given a triangle, now most of you guys will remember this. Sohcahtoa, as long as you know Sohcahtoa, you're good, all right? So, when we are given a triangle like this, a right triangle, we have three sides that make up this right triangle. Okay, this long side, who remembers what that is called? Who remembers what this long side is called of a right triangle? Hypotenuse. Yeah, very good, Abby. Or Maddie. The hypotenuse. There you guys go. Good. So our hypotenuse, and let's put our angle that we're dealing with down here. Okay. Now, the Greek letter, this is a Greek letter. Does anybody know how to pronounce the Greek letter? The Greek letter. Anybody know how to say that letter? Then you didn't learn it, Maddie. If you learned it, you remember it. That's me casting shade now. All right, yeah, hold on. I need to back up. Sorry. All right, this is actually means theta. Okay, theta. Okay, and here's basically what you need to know about theta. All right, theta is just basically simply basically the variable for an angle. All right, we don't use x there. We don't put an x there. We'll put an x on the side lengths, but for angles we use theta. Okay. So it's like this angle right here. All right. Now, there's two other sides. We have adjacent and opposite. Okay. The side that's always opposite the theta angle will be the opposite. And the side adjacent to it will be the adjacent. We'll kind of get to that. We will get to that a little bit later. Now, this is where in geometry you all would have gotten into side, angle, side when you're given, and all that stuff comes from a triangle and what it gives you. Like side, angle. If it gives you two sides, then an angle. If it gives you angle, side. We'll get into that a little bit later. All right. I think so. I'm not sure if we get too much into that or not, because with right triangles, all right triangles, you do start with one angle, and most of the time, if you can get just one other side, you should be, or two sides, you should be fine. So I don't know how much we'll get into it, but you'll see a little bit of it. All right. This is your main gist. You need to know the hypotenuse is always the longest side. The opposite is always opposite the missing angle or the angle that's given. And adjacent is always the one that's adjacent to the angle. All right. The Greek letter theta kind of represents what I'm going to say is a variable. Kind of represents the variable, but we don't use x. All right? Okay. Now, in trigonometry, there are basically 6 trigonometric functions. 6 trig functions. Okay, 6 trig functions. Okay, so those 6 trig functions, one of them is sine theta. So you will always see theta with sine, because when we say something like sine of 2, Sine of 2 is not just the number 2, that's sine of 2 degrees or 2 radians. It has to be either degree or radian. So anytime you see sine, you're going to see something attached with it. Whatever's attached with it is what you're dealing with here, okay? So if you see sine of 90 degrees, that's sine of 90 degrees, all right? If you see, sine of 1, that is simply sine of 1 degree or sine of 1 radian. And we discuss later the difference between degrees and radians. But for this purpose, you don't need to know that. What you need to know is that sine theta is equal to, now, but before I even tell you what it's equal to, I need you to understand that sine, people start getting trippy with sine and stuff because they're like, man, I just don't understand sine. Where in the world is sine coming from? Keep in mind, sine is just a function, all right? And keep in mind what a function is. A function is kind of like a box. You put a number in, you get a number out. Okay? So sine of whatever you're looking for, if your function is sine, now sine is spelt with an E. I probably should, let me do this. So that's sine there. So sine is actually spelt with an E, but we use the abbreviation of just S-I-N for sin. But we still say sine, not sin. Make sure we don't mess up that. So sine is just simply a function. You put something in, you get something out. Just like x squared is a function. You put something in, you put a 2 in, you get a 4 out. You put a number in here for sine, you're going to get something else out when you do it. So these are just functions that have been created. That was created by mathematicians a very long time ago. So they're just basic functions. Key word right there, basic functions. We have talked about, name all the basic functions we're talking about. X squared, x cubed, absolute value of x, 1 over x, x to the, radical x, the cube root of x, right? We've done those. Now we even know, what was I thinking of? B to the x, that we know that's exponential. We know that's a parabola, a snake, a v. The reciprocal function, they go opposite. Square goes to the right. That's a snake sideways. That's the exponential function. Now we're adding 6. Now we're about to add 6 more functions. In sine, cosine, and on and on and on. So again, guys, these are just basic functions that when you type in a number, you're going to get this. You're going to get something. So just wanting everyone to kind of understand that. Don't get trippy on me when people say, hey, what is actually sine? It's just a function. It's just like x squared. It's just like x cubed. It's a function. Now, if we look at sine on the calculator, we go to sine and we'll just say sine of x and graph that. Now, I may have to zoom in a lot. Sorry, I was in the wrong mode. Needed to change my mode. That's not sine, but let me zoom out now. That's probably too far. Yeah, there we go. We see this cycle of sine right here. So this is actual sine, and we'll talk more about how this deals with trigonometry on a later basis. But this is the function of sine. It's the same thing that repeats on and on. It's just a function is all I'm trying to get you to understand today. It has a graph just like x squared has a graph. It's a function. Now, the question may be, well, what's happening? What's happening? Some of you may say, well, I understand what's happening here, but what operation is happening in here? And that's what we'll kind of talk about today, and what operation is sine and what is it doing, okay? Now, we're doing it based on more of triangles today to get an introduction to it, but we'll kind of define that at a later time. So, sine theta is simply opposite, the opposite side over the hypotenuse. Okay? Sine, opposite over hypotenuse. Cosine, written like this, short is cosine theta, is equal to, and we'll never say cos theta, just say cosine, but we don't have to write it out. Cosine theta is equal to adjacent over hypotenuse. And then lastly is tangent. Tangent theta is just tangent is equal, or tangent theta is equal to opposite over adjacent. Now, each one of these has a reciprocal function. Guys, each one of these has a reciprocal function. What's reciprocal? Just simply flip it. All right? The reciprocal of sine is what we call cosecant. Cosecant. All right? Its abbreviation is CSC theta. And it is equal to hypotenuse. It's just this flip. Hypotenuse over opposite. The reciprocal of cosine is secant. And secant is just SEC theta is equal to just the reciprocal of this. Hypotenuse over adjacent. Again, guys, these are just simply all functions. These are still functions within itself. And then the last one is cotangent. Which is just COT theta is equal to adjacent over opposite. Now, the thing is, you have to memorize these off the top of your head. So a long time ago, people created this same, and Christina was the one that kind of typed it in, but she absolutely butchered it. She should be embarrassed by it. But it is this right here. Is that when we use sine? No. Good question. Actually, that's a really good question, Abby. And no, that is not the case. We do not, these are not the same thing as secant to the negative 1. And I don't know if you're talking about like on your calculator. Secant, like it's kind of hard to see here, but it's actually says sine of negative 1 there. Those are just, keep in mind, what does negative 1 mean? It's the inverse, okay? The inverse of sine, the inverse of cosine. But notice on your calculator here how this right here, how there is no CSC or secant or cotangent. It's just sine, cosine, and tangent. All right, and trust me, we'll get to that here in a little bit. And basically, what these over here are on the calculator would just be 1 over sine, 1 over cosine, 1 over tangent. And you may be saying, well, how is that the case? Because think about what cosecant is. I'm saying that cosecant is 1 over sine. Well, what is sine? Sine is opposite. That'd be 1 over opposite over hypotenuse, right? You with me on that? So then when I write that at horizontal, 1 over 1 divided by opposite over hypotenuse, I bring this one down, change the sign, do the reciprocal. I get, what do I get out of this? Hypotenuse over opposite, which is, I get hypotenuse over opposite, which is cosecant. So 1 over sine is the same thing. So the reason you won't see a cosecant, a secant, and a cotangent button on your calculator is because it's just 1 over its the reciprocal of it. Okay, so we just say 1 over sine, 1 over cosine, 1 over tangent. Does that make sense? Okay, cool. Now, so Kelsey's saying I use orange hippos always have orange ankles. So, and if some of you like, where's she getting that from? Orange, the O here, orange hippos always have orange ankles. Okay, and I've heard of that one. What the Sohcahtoa does, Sohcahtoa includes these letters as well. So it looks like this. So that's sine opposite hypotenuse. Sine opposite hypotenuse. And then so CAH, which is cosine adjacent hypotenuse. And then TOA, TOA, would be tangent opposite adjacent. You use whatever you need to use to remember. I don't care what you use, okay? What you use is totally up to you, and it doesn't bother me what you're going to use. As long as you're getting it. Now, I'm going to tell you this. Just in my experience, I've always found it so easy to do this right here. S-O-H, and then TOA. That's what I've always written it like that right there. That's always kind of helped me, and that's just the way I've always done it. Is just Sohcahtoa and then writing the O over the H, so then I kind of know what's happening. All right. All right. So look at this. This is people. Oh man, you all just missed it. Let me. Oh, you can't see it. Oh yeah, there you go. This is when it's bad. I know it's kind of hard to see. It says Josh Hoppock, your order is now ready. My wife, she can't be going to Chick-fil-A without me. It comes through my phone. It tells me when she orders it. So I'm sitting here teaching class to a bunch of coronavirus kids, and she's out eating Chick-fil-A. All right. Nonetheless, let's continue on. So, all right. This says find all values of the trig function. So, actually what I want you to do is just kind of erase out that one function that it gives you. You'll do the same thing on your homework. I repeat, you will do the same thing on your homework. At the end, I'll kind of show you what I'm talking about on your homework. So just erase those little marks, and what we want to do is we want to find all values, find all the values of the trig function. And I should say trig function. So basically what I'm doing here, I want us to get practice in identifying what is what. All right? So what I want to do is I want to find sine, cosine, tangent, cosecant, secant, and cotangent of this triangle. All right? And here's the thing. It's pretty simple. These are pretty straightforward and pretty simple, guys. The only thing you got to do is just write down the numbers. If it can simplify, simplify. If not, that is your answer. All right? So pretty simple here what we are going to do. All right, so this first one. All All right, so number 1. So find all the trig values of this whole triangle. So I'm literally going to do this. Sine equals cosine equals tangent equals cosecant equals secant equals cotangent equals. Now, here's what we know. We know this right here is hypotenuse, right? The long side's always hypotenuse. The side opposite the theta angle is always going to be opposite. And the side next to it will be the adjacent. Okay? Now that we have all that, we just need to plug everything in. Now again, I start most by doing this right here. Sohcahtoa. And then we just jump right in. Sine is opposite over hypotenuse, 12 over 13. Cosine is adjacent over hypotenuse, 5 over 13. Tangent is opposite, 12 over adjacent, 5. Give me a thumbs up if that makes sense to everybody in the room. All right, cool, Abby. Cool, Maddie. Good, Kristen. Good, Kelsey. Good, Christina. All right. Now, for the other 3, they're just the reciprocals. So once you find those, it's just flipping it. 13 over 12, 13 over 5, 5 over 12. Boom, we're done. Okay? That's what we're looking for there. Jumping to number 2. So, again, long sides of the hypotenuse, side opposite the theta angle is opposite, and adjacent's next to it. I'm going to go ahead and write everything out. Sine, and hey guys, I should be over here saying I want us to do this on this one. I apologize, I'm getting in a hurry. I should have said theta in front of all of those. Same thing over here. Sine theta is equal to, cosine theta is equal to, tangent theta is equal to, cosecant theta is equal to, secant theta is equal to, cotangent theta is equal to. Make sure you always include the theta. All right, so here we go. Same thing. And I'm doing this just so we get experience with it. Sohcahtoa. Sohcahtoa. Sine, opposite over hypotenuse. Opposite over hypotenuse. 24 over 25. Cosine, adjacent over hypotenuse. 7 over 25. Toa, opposite over adjacent. Opposite over adjacent. 24 over 7. And then we just flip them all. 25 over 24. 25 over 7. 7 over 24. None of them can be simplified, so we just keep it where it is. Okay. Going to this next one. So again, number 3. Now notice in number 3 we're missing a side. So what is that theorem that we use when we have a right triangle and we're missing a side? What's that theorem called? Pythagorean. And I am butchering the spelling of it as well, so I apologize. Yeah, Pythagorean. Okay? So here we have 8, 10. Okay? We have 8 and 10 here. So that's the hypotenuse. And this is a side. So remember, Pythagorean theorem is a squared plus b squared equals c squared. So I have an a. I have one of the legs. I'm missing a leg, and I have the hypotenuse. 64 plus b squared equals 100. Subtract 64 from both sides. We got b squared is equal to 36. Therefore, b is equal to 6 when you do the square root of both sides. So that right there is equal to 6. Now we have that knowledge, we go and get all trig functions. Sine theta equals cosine theta equals tangent theta equals cosecant theta equals secant theta equals cotangent theta equals. Okay, so then we just identify, so opposite, adjacent, hypotenuse. All right, so, and then Sohcahtoa. Sohcahtoa. Sine is opposite over hypotenuse. Opposite over hypotenuse is 6 over 10, which simplifies to 3 over 5. Cosine is adjacent over hypotenuse, which is 8 over 10, which simplifies to 4 over 5. Tangent is opposite over adjacent, 6 over 8, which will go to 3 over 4. And then we just do the reciprocal. 5 over 3, 5 over 4, 4 over 3. Give me a thumbs up. We feeling good? Very good. Let's go to number 4. So 4, 3, and obviously, guys, you could do this Pythagorean theorem in your head. Since they're both sides, they're both going to be on the left side here. So that's 16 plus 9, which is 25. The square root of 25 is 5. So 5 right here. 5 is our missing side. I say sine theta is equal to, cosine theta is equal to, tangent theta is equal to, cosecant theta is equal to, secant theta is equal to, and cotangent theta is equal to. I have my hypotenuse, I have opposite, I have adjacent. And my thing is Sohcahtoa. So here we go. Sine opposite over hypotenuse, 3/5. Adjacent over hypotenuse, 4/5. Tangent opposite over adjacent, 3/4. And then we just flip it all. 5/3, 5/4, 4/3. Okay? Moving to the next page. Okay? Now, we won't find them all. We'll just find whatever it tells us to find, okay? We won't find them all here. We're just going to, from here, we'll find whatever it wants us to find. All right? So, as stated here, if you're missing an angle or if you're missing a side, if you are missing a side in a right triangle, yes, that would be correct, Maddie. For 1 through 4 in the homework, you do it for all functions. If you're missing a side in a right triangle, use Pythagorean Theorem. I didn't know I had something like that on the front, so that's what that empty space was for there. All right? So, and guys, there's a thing that are called Pythagorean Triples. There's only a certain number of side lengths that triangles can be in order for it to be 90 degrees. Those are called Pythagorean triples, like 3, 4, 5, 6, 8, and 10. Okay? There's only certain number of those, and it would help to kind of, you know, or the easy ones like 6, 8, and 10, 3, 4, and 5. What else did we see back there? Yeah, 7, 24, and 25, 5, 12, 13. Those are some of the most common right triangles out there. All right. So, what's sine theta of this? All right. So we're just looking for sine theta. So sine theta. 1 second. Hey, bud. All right. Sorry about that. So sine theta of this triangle, sine is opposite over hypotenuse. So I normally label, just to make sure I'm good, opposite, hypotenuse, and adjacent. So sine is opposite over hypotenuse, which is 8 over 10, which is equal to 4/5. Okay, look at number 6, sine theta. Now, guys, before I even go and try to find another angle, I'm going to ask myself, did it give me enough information to answer the question? So sine theta, do we use the sign button on the calc for this? No, you don't. Nope. You don't need your calculator for any of this. You guys are good. Once we get to the back, that's what we'll get to the calculator here in a minute. All right. So from this right here, you need to ask yourself, because sometimes it'll ask you for a trig function, but then like within the triangle, it'll already give you your answer without finding the other angle. But we know that sine is opposite over hypotenuse, so opposite would be here. So we would need this angle. All right. We have a hypotenuse, you know, but we don't have the opposite of the theta angle, so that means we're going to have to use Pythagorean theorem to go find it. So Pythagorean theorem, of course, is a squared plus b squared equals c squared. Notice that it has given me the hypotenuse and one of the legs, so I'm going to say 2 squared plus b squared equals 2 radical 5 squared. All right? 2 squared is 4 plus b squared is equal to, now watch this. Remember what this is called? There's a multiplication sign right there between those. This is called a power of a product. You got to know your exponent rules, okay? This is a power of a product. So you got to raise the square to here, and you have to raise the square to there. All right? 2 squared, so this would actually look like this. 2 squared times radical 5 squared. That's your technical, that's the way that looks if we were to break it down. It has to go to both of them. So then I have 4 plus b squared is equal to 4. And then as Abby said, won't it just cancel? Yeah, it will cancel. Or you just remember a radical 5 times radical 5. Anytime you have the same radical multiplied by itself, it's just whatever's on the inside, right? Or you can just simply cancel them. Either way you want to look at it. 4 plus b squared is equal to 20. Subtract 4 from both sides. We get b squared is equal to 16. And b is then equal to, when we do the square to both sides, is equal to 4. So we got 4 right there. Now, sine, so sine theta, therefore is opposite over hypotenuse. 4 over 2 radical 5. Now, is that my final answer? Yes or no? Good, Christina. It's not. So you can actually simplify the 2 and the 4 because it's multiplying, right? Now, if it said 2 plus radical 5, then we couldn't. But we can simplify the 2 and the 4. 2 will go into itself once. It'll go into 4 twice. So now we have 2 over radical 5. Now, is 2 over radical 5 my final answer? I got a no and I have a yes. Explain why not. Explain why, Maddie, or explain why, Lucy. I don't. Both of you type it. Whatever. Why you think it is what it is. Why you say yes. Why you say no. There you go. Yeah, Christine's correct. You cannot have a radical in the bottom. We call that rationalizing denominators. Okay, rationalizing denominators. So technically here, Maddie, you were close. We don't have to multiply by the complex conjugate. You're good, Lucy. You don't have to multiply by the complex conjugate. You just really multiply by what it is to get it off. So radical 5 and radical 5. Multiply top and bottom by radical 5. Now again, radical 5 times radical 5 leads us just to 5, and then 2 times radical 5. So our sine theta there is 2 radical 5 over 5. Does that make sense? Give me a thumbs up from everybody. All right. Looking at cosine. So those are 2 sine problems. Now we look at 2 cosine problems. So cosine, we have 12 and 15. Now again, if you thought about what we did on that front side, see if we had one that was 12 and 15. We did not. So let's find, we're going to have to find this, whatever that measurement is. So a squared plus b squared equals c squared, Pythagorean theorem. So we have a leg and we have a hypotenuse. Y'all ready for a Bible joke? Nah. All right, Bible joke time. Just because Christina wants to hear a Bible joke. All right. You know that the man that was packed to the gate beautiful every day, right? Someone packed him to the gate of beautiful every day. Y'all know what story I'm talking about in the Bible? The man that was packed to the gate beautiful every day, and he asked for alms. Probably not, because you all know about as much Bible as a 2-year-old. No offense. You know I love you. Oh, Christina already knows it. Yeah, okay, yeah, cool. Christina knows. Yeah, hey, actually, good point. Good point, Abby. Thanks for interrupting my joke. Maybe we don't even need it. See, I'm not even listening to my own advice. But going back, yeah. John and Peter went by, and there was a man that was lame, and he could not walk. You with me? John and Peter came by, and he said, hey, this guy said, hey, can I have some alms? All right? And then Peter said, I'm pretty sure it's Peter said it to him. It may have been John, but one of them said, I don't remember if it specifies, but they said, silver and gold have I none, but such as I have give I thee in the name of Jesus. Now rise up and walk. Miraculous moment, big time moment in Bible history. Somebody was asking for alms, and Peter and John turned and said, hey, look, we ain't got no money. We ain't got gold and silver, but what we have in us, we give it to you. Now rise up and walk. Very, very powerful thing. But here's the joke in it all. The guy, the lame man at the gate, he was asking for alms, but got legs. That's a good joke. That's a solid Bible. That's a solid Bible joke. No. That is above dad jokes. That is that's a solid joke right there. Use that one at dinner tonight. Use that one at dinner. The man, because your parents are going to be impressed with you because they think you read the Bible, for one. But you don't even have to give me credit. Don't even give me credit for it. Don't even give me credit. But the man at the gate beautiful was asking for alms, but he got legs. I don't care what you say, Christina. All right, sorry. Going back to the point that Abby pointed out. Abby said, hey, cosine is adjacent over hypotenuse. So what are you doing, Mr. iPod, going to find that? Because what we have is we actually have adjacent over hypotenuse. And Abby is 100% correct. So we don't need to go find that. So knowing that won't help us because, remember, it is Sohcahtoa. And remember I told you, like, sometimes you might not have to find the missing angle. Always check, but I didn't check because I was prepping for my joke, really. So cosine is adjacent over hypotenuse. So cosine theta here is equal to 12 over 15, which is equal to 4 over 5. Okay. All right, going over here to number 8. All right. So cosine. So cosine Sohcahtoa. We need adjacent over hypotenuse. Adjacent, that would be opposite, and that would be hypotenuse. So hey, look, same thing here. We don't know this angle, but we don't need to know that angle because we're just looking for cosine. All right. So adjacent over hypotenuse is 5 cosine theta is equal to 9 over 5 radical 10. Now, is that our final answer? No, very good. So what do I need to multiply top and bottom by in order to rationalize the denominator? Okay. Now, Christina says 5 radical 10. Now, we can multiply that by 5 radical 10, but it's just going to make it a little bit more work. Really, we can just multiply top and bottom by radical 10. We don't have to multiply by the whole denominator. We just need to multiply by that right there. Because keep in mind, this looks like that on the bottom. 5 times radical 10 times radical 10. And it doesn't matter which way you multiply, right? So you can multiply just those two first. So on the top, I have 9 radical 10. And on the bottom, radical 10 times radical 10 is 10. But then 10 times 5 is 50. And I know 9 won't go into that. Nothing else will go into that. So guys, that right there would be my final answer. All right, skip it down here to number 9. Tangent. So keep in mind, Sohcahtoa. Toa is opposite over adjacent. So here we have opposite, here we have adjacent, and here we have hypotenuse. So unfortunately here, we're going to have to go find the opposite here in order for us to get this. All right. So in order for us to find tangent theta, we're going to have to find that other side. So that's a squared plus b squared equals c squared. So that's 15 squared plus b squared equals 17 squared. Good thing we know those squares. 225 plus b squared equals 289. I subtract 225 from that. I get b squared is equal to, what is that, 64? B is then equal to 8 when I do the square root of both sides. So that's 8. So tangent theta is equal to 8 over 15. Okay. Jumping over here, tangent. Again, tangent is TOA, opposite over adjacent. Opposite over adjacent. And then that would be hypotenuse. Now here, notice we need the adjacent, so we got to go find it. So 15 squared plus b, again, a squared plus b squared equals c squared here. 15 squared plus b squared is equal to 5 radical 10 squared. That's 225 plus b squared is equal to 25 times 10. That's 225 plus b squared is equal to 250. Subtract 2 1/4 from both sides. I get b squared is equal to 25. B is equal to 5. So my adjacent is 5. Then I have opposite 15 over 5. Tangent theta is equal to 15 over 5, which is equal to 3. Give me a thumbs up. We feel pretty good about all that? Cool. Let's go to the next page. Okay. So this right here, we're finding the missing side when given side aside, an angle, and an angle. Okay? So finding the missing side when you're given side, angle, angle. Again, we are given a side. We know that that is 90 degrees right there. So we're given, it gives us 2 angles and a side, and it wants us to find another side. Now, once we find one side, then we can literally find all sides. Or once we get, 2 sides, then we can find the third one using Pythagorean Theorem. All right? So, here is how we go about this, guys. Here is how we go about it. We know that basically trig functions are ratios of the angles. Okay? Again, this whole time we've been doing sine theta is opposite over hypotenuse. We've been doing all that, all right? So let's keep that. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Sohcahtoa. So, right here, guys, this is where I say, okay, I'm wanting to find this, but this and this right here are some kind of trig ratio to this angle right there. Okay? So you ask yourself, well, what trig angle is it? Well, look at this. To this angle right here, this is opposite, this is adjacent. Or no, excuse me, this is hypotenuse, right? So, which one of these has opposite over hypotenuse? Sine, cosine, or tangent is opposite over hypotenuse. Well, sine is. So watch this. Sine, very good, sine of 70 degrees of this triangle is equal to x opposite over hypotenuse. Now again, we are just setting up a ratio. We're doing what we've just been doing on this whole other side, guys. We're just now using a kind of a different reference, all right? So we're looking for this right here. Well, in order to find this, we're going to have to set up an equation, all right? So what we say is, what ratio is this x and this 16 to the 70 degrees? Well, it's opposite over opposite over hypotenuse to 70 degrees. which is sine. So we say sine of 70 degrees is equal to x over 16. That's literally what we've been doing this whole time. But now we just take it one step further. All right? Give me a thumbs up if you're seeing this. I know this can get a little bit confusing because we just went to like sine 70 degrees equals x over 16. But let me know this is making sense to you. Good, Kelsey. Good, Abby. Good, Maddie. Good, Lucy. Good, Christina. All right, good. Very good. Very cool. So then from here, what we need to do is just isolate x to see what x is. So we multiply both sides by 16. Now, we don't know what sine of 70 degrees is. Okay, we don't know what that, and again, that'll make a little bit more sense a little bit later on. But sine of 70 degrees. Now, keep in mind that I don't want to just throw you in the dark and say, well, what in the world does that mean? Okay, keep in mind, guys, that if we had a triangle like this, if we had like an XY coordinate, right? And we know that's 90 degrees and that's 0 degrees. Keep in mind that 70 would be about right here. And it'd be like making a triangle out of that 70-degree angle right there. Okay? So that's kind of where that whole sine of 70 degrees is coming from. Okay? But we're not going to calculate like that. We are going to use our calculator for this because no one wants to calculate sine of 70 degrees on paper. All right, so I'll get my calculator out. Now here's, guys, is where we got to check one thing. Do everyone see the mode button to the right of second? Hit mode. And under mode, right here where it says radian and degree, what should we be in right now if we have a degree symbol in our problem? We should be in degree mode. Okay? We should be in degree mode. Very good, Christina. So once you've clicked on degree, and then just hit second quit. And that takes you back to your home screen. Now, we just type it in what we see, guys. 16. And then I'm going to say sine, which is to the right of the inverse. Sine, 16 sine of 70. Now, I don't have to put degrees because the calculator knows it's in degree mode. So I don't have to say 16 sine and then go look for a degree button. I just say 16 sine of 70. I hit enter. I get 15.03. It says round to the nearest tenth. So 15. So x is equal to 15. Okay. Sorry, I was just looking at something. Okay, so that is that. Now, some of you may be saying, well, could we do the same thing with 90 degrees? Now we could, okay? We could do it with 90 degrees, all right? So if we had 90 degrees and here was my hypotenuse, and this right here, this is where it gets a little bit tricky, okay? It would be hypotenuse over and that's where, see how it would get really confusing? Well, what's my opposite? What's my adjacent? Because it seems like this right here would be my opposite of 90 degrees. So that gets where it gets really confusing. And I would just always go with what it gives you, okay? Okay. But even if you're like, well, I don't like that answer from you, Mr. Hypotenuse, think about this. 90 degrees, if this is my hypotenuse, it would be hypotenuse over x, which would be adjacent. So I'd have to use secant. And that would be 1 over cosine. And trust me, guys, just trust me in the fact that it gets nasty. Okay? So I could use this, okay? This would be the hypotenuse. This would be opposite. This would be adjacent. But then I couldn't use cosine. I'd have to use hypotenuse over adjacent, which is secant. And that's 1 over cosine, so it gets real nasty there. All right? So just trust me in the fact. Go with the degree it gives you normally here. All right? So let's jump over to number 12. So 33 degrees is what we have. We have Sohcahtoa. So what is this? What are these to the 33 degrees? That's opposite over hypotenuse, right? It's opposite over hypotenuse. So opposite over hypotenuse is sine. So let's say sine of 33 degrees is equal to x over 5. I multiply 5 on both sides. And guys, make sure it always makes sense. Like if the hypotenuse, we said the x here was 15. Well, the hypotenuse is 16. So that makes sense. The hypotenuse is the longest side. So always make sure it makes sense. And then x is equal to, grab your calculator and just type it in. 5 sine of 33. 5 times sine of 33. 2.7. Okay? And that would make some sense. It's the smallest side on there. So yeah, that makes sense that it would be 2.7. Okay, now, just because I want to prove, I feel like I'm giving you kind of a, Maddie, I'm sorry, I just saw where you had said, so when did we switch it back? Here's the best thing. I get asked this question all the time. When do I know to be in radian mode? When do I know to be in degree mode? If you have a degree, be in degree mode. If you have radians, which is mostly anything else without a degree sign, mostly pertaining to pi, but if it has a degree in the problem, you're going to be in degree mode. If it doesn't have a degree, you're going to be in radian. All right? So, but what I feel like I don't want to confuse you too much with this, but I do want to show you that, look, all these trig functions do work. So I want you to notice this, because some of you may be seeing this, like, well, Mr. Alpok, you say that x over 5 is opposite over hypotenuse. And that's true, and that's what we use here. But some of you may be saying, well, I see it like hypotenuse over opposite. Okay? Now keep in mind that hypotenuse over opposite is the reciprocal of sine, which is cosecant. All right? So let's say you went that route. Let's say you said, you know what? 5 over x is hypotenuse, according to 33, this angle of 33 degrees. 5 over x is hypotenuse over opposite, which is the reciprocal of sine, which is cosecant. So you could be saying, well, cosecant of 33 degrees is equal to 5 over x. And why can't I do that? And the answer is you can do that. Okay? You can do that, but watch the difficulty of it. It's not difficult. It's not hard or anything. It's just more steps because you're dealing with the reciprocal then. All right, and you don't have a reciprocal button in your calculator. But from here, we want to isolate x. So we'd multiply both sides by x. That cancels. And then I get x times cosecant of 33 degrees equals 5. Then isolate that x by dividing both sides by cosecant of 33 degrees. Cancels, and I'm left with x is equal to 5 over cosecant of 33 degrees. Now, on your calculator, you don't have cosecant on there. You don't have cosecant, and those, as I explained to Abby a little bit earlier, those inverse of sine, inverse of cosine, inverse of tangent, those are not the reciprocals. Those are the inverses. So, but what did I tell you how would you type cosecant into the calculator? Somebody type that in the chat box. How do you type cosecant into the calculator? Yes, Christina, 1 over what? Yeah, good, Maddie, 1 over sine. So the way this would have to look would be x equals 5 over 1 over sine of 33 degrees. Okay? So type that into your calculator. Alpha y equals enter. 5 over, then do another alpha y equals fraction and do 1 over sine of 33 degrees. And we are in degree mode. So that's what we get, and we get 2.732, which is the same thing we found here. 5 times sine of 33. Okay? Just showing you, you have options here, okay? But I would stick to kind of I would ask myself, what makes this easier on me? Okay? What makes this easier on me? Thank you, bud. 1 second. I got to plug something in. Want to say hello?
Hello.
Okay. That is that. All right. So now let's continue on to 13. Okay, 13. Looking at 13. So 13, let's see what we're dealing with here. So this is opposite over hypotenuse, right? Opposite over hypotenuse. So that's pretty simple. We just use sine there. Sine of 48 degrees is equal to opposite over hypotenuse. Now notice here, I did not have my, I don't have x on the bottom here, but that's okay. Just multiply both sides by x. Cancels. And get x times sine of 48 degrees is equal to 11. Then divide both sides by sine of 48 degrees. X is equal to 11 over sine of 48 degrees. 14.8. And that should make sense. Again, I always write it in there, 14.8. Write it just to make sure. That side's 11, so 14.8, that would make some sense. Okay. Looking at number 14. Actually, you guys feeling pretty good? I haven't talked to you in a minute. Give me a thumbs up. That's making sense. Thank you, Kelsey. Good, Abby. Good, Christina. Good, good. Okay. So, 14. What would I use on 14? What trig function? I got 56. I got this x and that 7.9. What trig function would I use for number 14? Good, good. Maddie, tangent. So tangent of 56 degrees is equal to opposite over adjacent, 7.9. Give me a thumbs up if we're all understanding that. We all get that. Just want to make sure. It's kind of hard without seeing your faces. Okay, good, Kelsey. Good, Abby. Good, Maddie. All right. So then multiply both sides by 7.9. So 7.9 tangent of 56 degrees is equal to x. Calculator, 7.9 times the tangent of 56 degrees is equal to 11.7. Does that make sense there? That'd be 11.7? Yeah, it's a little bit longer than 8. Yeah, cool. X is equal to 11.7. Okay. This next one is find the measure of each function indicated. Round to the nearest tenth. All right. So this is finding the angle given. What are we given here? Like up here, like up here we're given angle, or side angle. Side angle right here. Know how we're doing that? What are they giving us down here? What are they giving us down here? It should be side angle side. They're giving me a side, they're giving me an angle, they're giving me a side. They're giving me a side, they're giving me an angle, they're giving me a side. Side, angle, side. Okay? Sorry, Wu, you are my guy. You are way too late, my friend. Okay. So, yeah. Now, here's the thing. As I see you all, like, coming through here, like, SSA, ASA, I don't want you to get too trippy with that stuff, okay? Don't get too trippy with, well, man, what is this? How do I read this? Side, angle, side, angle, side, angle, angle. Like, why can't I read it side, angle? let's not get trippy in that, okay? In pre-calculus, we may get into that a little bit more, but I'm not concerned with it right now because I could care less if you know what type of what it gives us. I care more about, can you figure out this angle based on what it gives you? I don't care if you can identify, oh, what is this? Because if you can identify it but still not be able to do it, it's pointless. I want you to be able to do it, and if you can identify it, cool. If not, not a big deal, okay? I don't want you to be tripping on this whole side angle side and side angle angle stuff, okay? I didn't teach you geometry, so that's more in that geometry stuff. We won't hit too much of that stuff going forward in pre-calculus and AP calculus for some of you, all right? So, looking at this right here, okay, what I want to know here is what is happening with this angle, okay? What is it giving us here? In regards to this angle, what trig function is it giving us? Opposite over adjacent. What would that trig function be? Tangent. Very good. So here's what we have, guys. We have 10 over 13. So 10 over 13 is equal to the tangent of this theta. So tangent of the theta. Okay? But what this is wanting to know is, what is this angle right here? What is theta? It's wanting to figure out what theta is. Well, that's easy. Tangent theta is 10 over 13. But once you got that, guys, you're good. You're good from there, okay? Once you have that, you are good. All right? Because you're going to make one little move that makes a difference, and it's going to be this right here. The -1, which means simply the inverse. So, when finding angles, use inverse trig functions. Which are sine of -1, cosine of -1, tangent of -1. So that's what I want you to remember in all this, is when you're finding this, okay, simply use your inverse, use your inverse trig functions when you're finding angles. This question's probably going to come up a lot, okay? This question will come up a lot, and that's when you got to use inverse trig functions. Okay? So, coming over here to our calculator. Here's exactly what we're going to do. All right? We're going to say second tangent, that's your inverse. And we don't have to, since tangent -1 theta is equal to 10 over 13, we just type that in as 10 over 13. And that right there is our answer, guys. Okay? 37, it says round to the nearest tenth, 37.6. Hey, good question. Good question, Maddie. Why would I change it to radian? Can you tell me? Okay, so Maddie said because we are using sides and not angles. All right. Keep in mind, what did I say? What are we doing when we're looking? How do we know when we use radian and when do we use degrees? We use degrees when we have degrees and we're looking for degrees. I'm looking for the degree of this angle. It says find the measure of each angle indicated. So 99.9% of the time, and the way I want you to do it on my homework, is going to be that when it says find the measure of each angle, that angle you're looking for will be in degrees. So we will use degrees here. 37.6 degrees. Okay? And that is what your answer sheet will be on the, that will be what your answer sheet will have as well for your homework. But if you need to change the mode. What did you say, Abby? Okay, cool. All right. So, all right, just making sure we are all good there. Okay, so jumping over here to number 16. So looking at 16, what does it give us? Opposite over adjacent, right? Opposite over adjacent. So opposite over adjacent, you know opposite over adjacent is Sohcahtoa. Always remember Sohcahtoa. So I'm going to use tangent. So the tangent, the inverse tangent, and really, guys, you can just write like this, the inverse tangent of, you can really just say the inverse tangent of 15 over 10, because that's the way you'll type it into your calculator. So we'll say the inverse tangent of 15, the opposite divided by the adjacent, 15 over 10, is equal to 56.3. Theta is equal to 56.3 degrees. Oh, my bad, guys. Don't mean to shake you. So what do you do when you're finding angles? Use inverse trig functions, okay? Use inverse trig functions. How about number 17? What does it give us here? Opposite over adjacent again. So the inverse of tangent of 15.4 over 13. $49.8 degrees. Something you want to make sure you do is kind of line that up. Look at that. Does that look like a 49-degree angle to you? Does that look like a 56-degree angle to you? Well, you know 45 would cut a 90 right down the middle, so it's a little bit more than 45. Does that look like a 37-degree angle to you? Same way we did with the sides, do the same thing with the angles. Make sure it sounds right. If it doesn't, you may have made a mistake. Looking at 18. 18. What would we use here for 18, guys? Good, Maddie. Cosine. So adjacent over hypotenuse, the inverse of cosine of the adjacent 6 over 15. And I got 66 point theta is equal to 66.4 degrees. How do we feel about finding missing angles? Okay, cool. Hey, last bit. I know we've been on here for about an hour and 30 minutes. Give me 10 more minutes. We won't do all the problems on the back. We'll just work 2 of them and be done. All right? So, for some reason, these didn't have directions on it, 19 through 22. I don't know why it knocked the directions off, but basically, what the directions were solve each triangle. You will need to add that to your homework for 19 through 22. Solve each triangle. Now, notice here we are given a couple different scenarios in these. This one we have a side angle. Okay, over here we have a side angle. So again, I don't want you to get too hype in that. I just care, can you do the work? Okay, that's all I care about. Can you figure out the work? All right. Now, again, this shouldn't take us 10 minutes. We may do more than 2. I just want you to get in the hang of this. So what does it mean to solve each triangle? When you see something that says solve each triangle, that means simply find all parts to it, which means all angles and all sides. Okay? Anytime you see something that says solve the triangle, complete the triangle, it simply means, guys, just find all the parts. Find all the angles and find all the sides. Now, who can tell me we got a 90 degree and a 43 degree? So this would be going back to geometry a little bit, bringing back geometry. What's the interior sum of all angles of triangles? What's the interior, meaning the inside? What is the inside sum of triangles? 180 degrees. Very good. So if I have 90 there and 43 there, so 90 plus 43 will be 133. And if the total is 180, I need to say 180 minus 133, right? And 180 minus 433 would be 47. So that's a 43 degree angle. That's a 90. And this right here, what we just found, would be a 47 degree angle. So I have all angles. Pretty simple, right? You all remember that? Now I just need to catch these sides up. Okay, I need to grab these 2 sides. All right. So I'm going to use the sides. I'm going to use trig functions right here, guys, to kind of figure that out. All right. And keep in mind, you can use trig. You can use everything we've done today to do that. But, if you've given 2 angles, there's no reason to find this side and that side to go find that angle. Just use common sense. And just know the interior sum of triangles is 180 degrees. So then just do this little easy method we did there. All right. Here, now let's say we want to find this side right here. Okay. Let's say we want to find this side, this x right here. So I would say what is this compared to 43 degrees? And again, it doesn't matter what angle you go with. Going with the 90 makes it hard because opposite and hypotenuse seem to be the same, and it gets a little confusing there. So I'd go with one of these, okay? And I'd ask myself, what do I have here? Do I want to go, I can go 43 degrees, and that would be opposite over hypotenuse, which is sine, or I could go 47 degrees and go adjacent over hypotenuse, which is cosine. Doesn't matter which way you go, you just need to find this right here. Okay? I am going to go sine of 43 degrees. So sine of 43 degrees is equal to x over 16 because I have my whole Sohcahtoa. I then multiply both sides by 16, and I get x to be, calculator, 16 sine of 43 degrees. Oh, sorry about that. I get 10.9. Just keep that trended round everything to the nearest 10. So 10.9. That makes some sense. If the hypotenuse is 16, that would make some sense. Okay. Now the question is up to you. So what do we want to do next? What do y'all want to do to find this side right here? Okay, yeah. So it's natural for you all to say, you know what, I'm used to Pythagorean Theorem, so I want to keep Pythagorean Theorem. But to be honest, Pythagorean Theorem, a lot of calculation, okay? A lot of math. There could be some error in there, okay? And plus, not all perfect square roots are nice and beautiful, okay? So the way I'm working, I think it's just easier just to use the trig, okay? So I'm looking for this x. So if I'm looking at this, again, I can pick either one of these angles right here. This is adjacent over hypotenuse, or I can say opposite over adjacent. I can go any direction I want. Are you all understanding like the multiple options you have here? Give me a thumbs up if you're kind of seeing, okay, I'm not just set to one way. I can use multiple angles to find using the different trig functions. Is that making sense to you all? Okay, good, Maddie. Good, Christina. Okay, so just making sure because it does seem like a lot, okay? So I am going to use this right here. I'm going to use, if I'm trying to find this, I'm going to use opposite over hypotenuse. So I'm going to say sine of 47 degrees is equal to opposite x over hypotenuse, which is 16. I multiply both sides by 16. X is equal to 16 sine of 47 degrees, and I get it to be 11.7. And I've just completed. I have all three sides. I have all three angles. I've solved the triangle. Now, is using Pythagorean Theorem wrong? Not at all. That's fine if you want to use Pythagorean Theorem. Again, Pythagorean Theorem is all about right triangles, all right? I just think, instead of doing a squared, b squared, c squared, and then, right, I just find it a little bit easier just to do that one step there, multiply both sides by 16 and see it. But do what you're comfortable with. You guys know I'm not a hater of that, all right? All right, last problem of the day, guys. Last problem of the day. I know this is a big one, but hey, again, I'm sorry, but I was planning on starting trig with you. As I told you before, I don't mean to be redundant, but I was planning on starting trig with you on April 14th. Okay, so we're about 3 weeks off of schedule due to obviously the coronavirus. So Forgive me that it's, we're going almost 2 hours here, but I just want you to know that, again, we're a little bit behind. So I'm trying to I'm throwing a lot at you, but I assume that you guys can handle it. All right. So look at number 20. I have side angle, but again, I told you I don't really care about like you understanding that in its whole thing. If you do, great. If you don't, not a big deal. I just care, can you solve this triangle? Can you use trigonometry functions to solve this triangle, to figure it out? Well, I have a measurement right here, which is 90 degrees. We know that. And I have my two sides. So I could easily use Pythagorean Theorem and get that other side. Okay? So totally up to us what we're going to do within that. But what I want to do is go find one of these angles. Okay? So let's say we go find this angle right here. 1 second. Sorry, I had to check on my son. So let's say we're finding this angle right here. So that would be opposite over hypotenuse. So I would just say the inverse sine of 9 over 12. The inverse sine of 9 divided by 12. That equals 48.6 degrees. Yeah, that makes sense. Now again, I could use my oh no, you're good, bub. I was just making sure you're fine. So you could use your 180 minus all this, or you can just simply say, all right, I'm wanting to find this angle. So this angle, that would be adjacent over hypotenuse. Adjacent over hypotenuse is cosine. So cosine, the opposite of cosine of 9 over 12. Adjacent over hypotenuse, second inverse, 9 divided by 12, would be 41.4. So that's 41.4 degrees. Okay. Now again, if you want to do the whole, interior sum is 180, subtract, I'm cool with that. I don't care. Now you may want to, just if it's your first time, we may want to just, try this all out just to make sure we're good. 48.6 plus 41.4, and that is equal to 180, just to kind of show you there. And then to find that missing side there, x, I'm just going to say opposite over adjacent. So I'm going to say opposite over adjacent is tangent. So tangent of 41.4 degrees is equal to x over 9. Multiply both sides by 9. 9 times tangent of 41.4 degrees is equal to 7.9. So that x right there is equal to 7.9. Again, you may be saying, how'd you do that? What'd you do? So again, you can use Pythagorean Theorem here, but I want to stay away from that just because I find it a little bit easier to do this. So I just took this angle here, 41.4. That's opposite over adjacent, x over 9. X over 9, multiply both sides by 9, you get 7.9. That should make a little bit of sense there. 7.9, 9 and 12. And again, easy way to always do that is just to square both of those and see if it equals 144. So 9 squared is 81. 7.9 squared is equal to 62.41. And so plus 81. And that's pretty close. Again, we rounded. Again, a squared plus b squared is equal to c squared. It's 143.4, but we rounded that 7.9. We rounded the angle, so it's not exact, but hey, I'm completely fine with that right there. And the answer key is 2. I just looked at the answer key. It's we have everything correct. Do you need to see me work another one of the solving the triangles, getting all 3 angles, all 3 sides? Are you all good on that or what? Hey, sorry about that, guys. My Oh, okay. Sorry. All right. So, yeah. Go ahead. Yeah. Go. You can go ahead and finish those rests, and I'll do. I'll work one. Lucy. I think Lucy said she'd like to see another one. That's cool. So, if I mean, if you're good, well, hold on just a second. So let me explain this. So the reason I brought up the 144 because think about what is I'm saying in order a way that you can check to make sure your sides are right is by doing the Pythagorean theorem. See, we didn't use any of the Pythagorean theorem down here to find that side, but the Pythagorean theorem says that a squared plus b squared should be equal to c squared. So I said a squared is 9 squared plus 7.9 squared should be equal to 12 squared, which is 144. So I was saying that if we were to do 81 plus whatever that is, it should give us 144. Okay? Okay. Lucy, I'm going to stay on here for you for a second, but give me some response. So I'm going to stay on here. I'll work 21 and 22, making sure everyone gets that. But if you're good to go, you're free. Just give me a thumbs up and say, hey, I'm good. Have a good day. We'll see you later. Before you go, tell me, how do you feel about trig now? Less intimidating? A little bit easier than what you thought? Good review for some of you, maybe? I don't know. Talk to me. Yes, Maddie, have a good day. Good, Kelsey. Glad, yeah. It's not bad. Quit crying, Maddie. It ain't challenging to you. Good review, Christina. Christina, you didn't even know how to spell sign at the beginning of the day. Hey, you too, Kelsey. Christine is saying, yeah, it was a good review. No, you're cool, Lucy. I'm glad. I'll be here to help you. All right, cool, Abby. Okay, cool. All right, those of you staying, we'll jump into it. Those of you are good, farewell. We'll see you some other time. All right, so if you want to go ahead and kind of work this out, I mean, I'm cool with that. Yeah, okay. I'm with you. I'm cool with that. I totally understand, Abby. So again, it's just take it easy, take it one step at a time. I guess I could have been like rushing through there a little bit, just kind of try not to be on here forever. But I'm happy to kind of go through it here with a few of you guys that are still on here. Okay, more than happy to see. And looks like we still have 8 people watching. So, all right. So looking at number 21. All right. I need all 3 angles and all 3 sides. I have currently, what do I have? I have 1 side and 2 angles. Okay, 1 side here and 2 angles right here. All right. Now, there's multiple ways to work this, just as we just discussed. Okay. But you can still use Pythagorean Theorem sum. You can use the interior sum of triangles is 180. You can do multiple things here. All right. I don't care which one you use, but I can't really read your mind in knowing what you like or knowing what you would prefer. Okay. So I'm just going to go at it. All right. And hopefully you can see a little bit. So I know that this is a missing angle, this is a missing angle, and I have a theta right here that I don't know as well. Okay? Now, in order to get this theta here, I'm going to need at least two sides. Okay? So I can't attack the theta yet. And again, if you think back when we were finding theta angles with the inverse trig, we had two sides. Okay? So I can't get this theta angle without having more than with just having one side. So that means I need to attack one of the sides first. All right. So I'm just going to look at 39 degrees, and notice this. This is opposite of 39, and this is hypotenuse, which is a very simple sine function. So I can say sine of 39 degrees is equal to x over 3. 39 degrees is right here. The opposite over the hypotenuse. Sohcahtoa. Okay, Sohcahtoa. It gave me opposite over hypotenuse. So then from there, I'll multiply both sides by 3. And I get 3 sine of 39 degrees is equal to 3 times sine of 39 degrees in my calculator is equal to 1.9 when I round. So this x right here is 1.9. Now I could use like a different variable there. I could say that's a and that's b, you know. I could easily do that. Okay. So, looking, and actually, sorry, that would be x, and then x equals 1.9, rounded to the nearest 10. Okay, now from here, I need to find this side. Two options. I can go over here and say a squared plus b squared equals c squared. Use Pythagorean Theorem, that's my c. 3 squared, that's my b, 1.9 squared plus b squared. And I'm missing this b, and I can find this side length right here by using Pythagorean Theorem. Okay? So that's an option. Or look at this angle right here. Just say, what is 39 degrees? This is adjacent to 39 degrees, and this is hypotenuse. So adjacent over hypotenuse is cosine. So you say cosine of 39 degrees is equal to adjacent over hypotenuse, adjacent of 39 degrees over the hypotenuse, x over 3. Multiply both sides by 3. 3 cosine of 39 degrees is equal to x equals 2.3. Now, if I continued in this right here, 1.9 squared is 3.61. So 3.61 plus b squared equals 9. Subtract, or say 9 minus 3.61. I get b squared is equal to 5.39 when I subtract that 3.61 from both sides. 5.39, and now I do the square root of both sides. I get b is equal to the square root of 5.39 is equal to 2.3. So I'll get the same answer there, okay? It's just two different methods. One using trig, one using, again, Pythagorean Theorem is right. That is trigonometry. So either way works there, okay? Same answer. Now I have all three sides. Now I just need to go find that missing angle. When you're looking for an angle, you use inverse trig functions. Inverse trig functions. So I have this angle, and I just want to use an easy inverse trig function. So I could say opposite over hypotenuse. I have the opposite of this angle right here. This angle right here, I have the opposite, and I have the hypotenuse. So I'm going to say the inverse of sine. And then sine is opposite over hypotenuse at this angle. So opposite's 2.3 over 3. Inverse sine, and I'm just typing this in my calculator, guys. The inverse sine of 2.3 over 3 is equal to 50.1 degrees. Now, if you said, well, okay, that's a trig way. And again, another trig thing is just saying, hey, 90 plus 39 plus x is equal to 180 degrees. So the three interior angles have to be equal to 180. So 90 plus 39 is equal to 129. And then x, and then I subtract 129 from both sides. 180 minus 129 is 51. Okay? Is 51. So again, we're not in any way, again, because we rounded this, we're not getting exactly 51, but you're fine with that answer. I'm going to be completely fine with that answer. Talk to me now. Does that make sense to you all, or still confusing, or what do you think? It's not overwhelming, Abby. You just have some options. You're good though. You have options, but again, just get all three angles, all three sides. Just take it one at a time. Hey, how about this? I want you all to work number 22. I'll come back in like 4 minutes, all right? So I'm going to mute my mic. Does that sound good? Why don't you all work 22 by yourself without me talking anything? Try to get, you got two angles. That says 73 degrees there, and that's a 90. So you just need to find that angle and those two sides, okay? So why don't you all do that? I'll give you a couple minutes. Okay, yeah. So all right, I'll sit here. I'll come back about 4:37. I'll give you about 4 minutes. I don't know where, Christine, I don't know where the link is. So in about 4 minutes, I'll come back on. I don't know. I don't see the link. I'm sorry. I guess it doesn't let me see it on my phone. I don't know why. Let me look on my computer. No, don't mess with it, bud.
Can you give me those things you just showed me? My frogs.
Oh, you got frogs?
Yeah, they're outside.
All right, let me know when you guys are done. Okay. So Abby's not done yet, but you don't feel like you can figure it out. Okay. Anybody else still working that I need to wait for? Okay, so Abby, talking to you like specifically, I think this what I'm about to do can help you. All right. If it's really kind of hard to like grasp, but you really understood the beginning of the work, now we're just kind of putting it all together. I think what we need to do is just simply make a bunch of different triangles. I don't know if that's what you tried, but let me do that, and we'll kind of walk through here. Okay. So I'm gonna go triangle here. Okay. So that's my replica triangle. I know it looks beautiful. So I have a side length here of 2. I have a 90-degree angle there and a 73-degree angle there. All right. Now, are you with me on this, Abby? Just making sure you're still with me. Okay, so I just want to find, we need to find all three sides and all three angles. It's given us two angles and one side, so we need to find the sides. So I'm going to put an X right here, Abby. Now, Abby, if that's 73 degrees here, that's an X, and that's a 2, what am I going to do to find X right here? What trig function am I going to use to do that? Sorry, I know it got a little blurry. Shh. Good. Opposite over adjacent. So tangent of 73 degrees is equal to x opposite over adjacent. X over 2. Now we multiply both sides by 2 and get x is equal to 2 times tangent of 73 degrees. 6.5. So watch this. This x right here is 6.5. But I'm not going to fill anything in yet, okay? Not trying to fill, I'm not going to put it over there or anything. Are you cool with that, Abby? Okay, now we make another triangle. I got 73 degrees. I have 90. And I have 2 right here. Now I want to find that x. So Abby, based on this information that I'm given right here, okay, what trig function would I use? Looking at 73 degrees, looking at 2 and x, what trig function would I use there? You with me on this, Abby? So what trig function would I use if this is 73 degrees? Okay, so what is tangent? Tangent is opposite. Opposite would be right here. So it wouldn't be tangent. Keep in mind, Sohcahtoa. What is 2 to 73? Yeah, there you go. Cosine. 2, no worries. No, not a big deal at all. 2 is adjacent. X is hypotenuse. So we're going to say cosine of 73 degrees is equal to, and it's 2 over x. Adjacent over hypotenuse. Okay? Now, the way we solve this is a little bit different, but that's, not a big deal. So we just multiply both sides by x. Cancels, and then I have x times cosine of 73 degrees equals 2. But in order to isolate the x, I got to divide both sides by cosine of 73 degrees. And then when I do that, I get x is equal to 2 divided by cosine of 73. equals 6.8. 6.8. Again, I'm not filling anything in yet, though. Are you good on that, Abby? Cool. All right. Now, you now have three sides. 2, 6.5, 6.8. Now, we'll get to filling them in here in a second. But in order to make this next triangle, we know that's 73 degrees. We know that's a right angle. This down here is theta, okay? And we know this is 2. That's what the problem gave us, okay? But in order to find, okay, this angle right here, you have to have two sides, at least two sides, okay? In order to find this angle right here, you have to have at least two sides. Or you just add these two up and subtract them from 180. So you could do this, 73 degrees plus 90 degrees plus x equals 180. And then you just solve for x. And that will give you that degree. Okay? And if you do it that way, that's completely fine. Alright? But if you want to do it the other way using a trig function, you're going to have more than one side. That's cool. So if you just added them and sub, that's fine. I will go ahead and explain this other way, just so we're, I don't want you to be, again, you know who I am, I don't want it to be a concrete. I want you to be able to see multiple ways. So, that's me pushing you a little bit, and I think you can handle that. So, in order to find a angle, you got to have at least two sides, all right? Well, we found this side right here, up here, to be 6.5. So, I would just put 6.5 in there. And then notice this is opposite over adjacent, which is tangent. So I would say the inverse tangent of 2 over 6.5. And I got 17.1. Now, I've rounded, so our numbers may be a little bit off, but it should be right around there. Does that make sense to you? Okay. So then, once we have all that, then we just come up here and we just fill it all out. So that was 6.5. That was 6.8. And that makes sense because the longest side is the hypotenuse always. This angle right here was 17.1 degrees. And then you're done. So you're only finding 3 things from each one of these triangles because it gives you 3. Okay? So it gives you 3, you got to find 3. I don't know if breaking it down like that helps a little bit or hurts or what, but that's kind of like taking more of just a piece-by-piece approach, which is completely fine. Any other questions of me? Anybody else who's hanging out still on here with me? Got any questions? No, I know. No, it's cool. Completely fine. Draw it out. I don't care. You got to draw 30 triangles. Draw 30 triangles out. I don't care. Lucy, if it's me, I didn't use any of those reciprocal trig functions. But if you do, you're fine. You just, when you type it into your calculator, just got to say 1 over whatever that is the reciprocal of. I would try to avoid them at all costs, but if you do have to use them, when you type them into your calculator, cosecant is 1 over sine theta. And right here, cosecant, and then secant theta would be the same thing as 1 over cosine theta. So you're fine to use those. You just got to make sure you use it like this in the calculator. And then, of course, tangent theta is equal to 1 over cotangent. And Dom, who I hadn't seen all day, said, when we're finding the last angle, can we do the inverse of sine? Yes, you can. So Dom, if I'm going back to this, we knew that this angle right here was 6.8. So you could use sine of opposite over hypotenuse. You could say the inverse of sine of 2 over 6.8. And that's going to be 17.1 as well. Lucy, did I answer your question? I'm not sure if that was exactly right. I don't know. We'll talk Wednesday about a Zoom on Thursday. We'll talk Wednesday about that, or somebody remind me. All right. Any other questions of me? Lucy, did that clear you up? Abby, you good? Christina, Dom, you guys all good? Oh, okay. Lucy, you're talking about this right here. So when we had x on the bottom when we're solving the hypotenuse thing here, that's completely fine. I would rather you do this than use the reciprocal trig function. Only thing, you just do one more extra step, multiply both sides by x, and divide by cosine. Right. So, Lucy, you can go like, and that's what makes this like really diverse, is because you can approach it with multiple different angles, or multiple different approaches. Is like whether you can use a reciprocal or what. You don't have to have the x on top. Like here, we had the x on top. That was beautiful. But here we had x on the bottom, but we're staying away from those reciprocals. We had x on bottom, but we can still solve it with x on the bottom. It's just one more extra step of dividing cosine on both sides. But I think what you're saying is this right here is the same thing as secant. I think that's what you're saying. Lucy, are you saying basically if you want to keep x on top, that that would be hypotenuse over adjacent of 73 degrees? So I don't know if this is what you're asking, but if it is, to do that right there, and then to say x over 2, and then multiply both sides by 2, that would be the same thing as doing this right here. You're going to get the same answer. You're going to get 6.8 from that because this is the same thing as 1 over cosine, which would make that the same as this right here. Not for sure if that's exactly what you're talking about though, Lucy. Christina said, I think I got 2 of the sides mixed up because when I was doing tangent of 73, I thought I was finding the hypotenuse instead of the right leg. Okay? And just be careful with it and just, take it piece by piece. Everything has to make sense. So an easy way to always see if you're right is to do Pythagorean Theorem with all these. So a squared plus b squared equals c squared. And then add all your angles up to make sure they equal 180. So that's a way you can check it. No, that's correct, Lucy. That's correct. It doesn't have to be in the function you're trying to figure it out in, no. As long as you're getting the answer, whatever function it takes to get it in. Again, it's multifaceted. And it's multi-way too. Just there's so many different ways. There's so many different parts moving at a time. That's why I say multifaceted. A lot of pieces, a lot of different ways to attack these problems. Any other questions of me? Okay, hey, so here's the thing, Lucy. You're saying that for the opposite side, we wrote it as x over 2. We're talking about right here, right? Correct? I want to make sure we're talking about the same thing. We're talking about this. Okay, so we said tangent of 73. The opposite of this angle right here is x. Keep in mind that tangent is equal to opposite over adjacent. Sohcahtoa. So the opposite of this angle is x. The adjacent is 2. So that's why we wrote it as x over 2. Were you looking at it wrong, or am I just confusing you even more? Okay, cool. I thought you were looking at it wrong, but now I was like, I don't know where you're coming at from. So sorry if I misspoke. Everybody else good then? Are you all good? Do we need to jump on a Zoom real quick, or are you all good? Yeah, not a problem. Okay. Yes, correct, Dom. Dom, what are you doing? Watching this late or something? But yes, the inverse of trig functions are for angles. Anytime you're trying to find an angle, you use the inverse trig function. I wonder if the mic picks up that dog. All right, if you guys are good, give me a thumbs up. I'll see you later something. Oh, cool. No worries, Dom. All right. Hey, you guys have a good day. And hit me up if you have any questions at all, guys. Just take your time through it, go through it. And like I said, I'm more than happy to answer any questions if you have them. Shoot them to me. You guys have a good day. I will never watch it, Christina. It's probably not funny. You oversell stuff. You really do sometimes. Overpromise, underdeliver type. I mean, this. I feel like we've gone through this before. All right. You guys have a good day.